In this lesson, we will learn about the different data cleaning and data preparation techniques. Michael is assigned with a new project that requires him to understand and utilize Excel for data cleaning and data preparation purposes. To complete the project, he has to learn to use the sort and filter functions in order to filter data. Group by and ungroup functions, as they allow grouping of data by collapsing and expanding rows with similar content to create more compact and understandable views. Remove duplicates function for removing duplicate data, and data validation function for any given data. Let us understand the concept of sort and filter. The sort and filter functionalities are available in Excel to order or filter the data for further analysis. Let us consider an example to understand it. Here, we have the results of 9 students for the math subject. Firstly, let's understand sort functionalities. In order to sort the values based on the CGPA in descending order, go to Data tab. A pop-up will appear under this. First select the CGPA column name, and then click on Sort, and click OK. It will sort the data and give you the result like this. We can do the same on non-numeric columns and multiple columns as well. Let us see how we can sort names in ascending order. Under the Sort by tab, select Name and Order as A to Z, and click OK. We will get the result in the sorted manner. Filter option allows us to choose any column we would like to filter the data on. Let us consider the same example. Now to filter the data, under Data tab, click on Filter. For example, we want to see the CGPAs that are greater than or equal to 4. So, we will choose the greater than or equal to option from the drop-down, and then mention the number. In this case, it is 4.0. Then it will filter all data and give results in this order. In this video, we will learn about group by and subtotal. Group by and ungroup by are available under the Data tab within Outline section. The group by functionality in Excel allows us to show necessary data and hide unnecessary data for easy viewing and analysis. We can also create subtotals and outline for a given set of data. Group by can be done for rows or columns. Let us discuss about the steps for grouping data. The first step is to select the rows and columns you want to group. Now, click on Group under Data tab. There will be a pop-up tab to choose either rows or columns. Choose columns and click on OK. This groups the 3 columns chosen and applies a control to show or hide the grouped content. Clicking on hyphen hides the content, whereas clicking on plus shows the grouped content. Similarly, for row-wise grouping, select the rows you want to group. Click on Group under the Data tab, and then select Rows option from the dialog box and click on OK. Here again, clicking on hyphen hides the content, and clicking on plus shows the grouped content. However, we can create a group within a group by choosing rows or columns within the group data. This will be the result. Let us now learn about ungrouping. The ungroup option allows us to remove the groups created by group. In order to ungroup, choose the data already chosen for grouping, either row or column. Click on Ungroup under the Data tab. Choose rows to remove row-level grouping. Now you will notice that the group chosen will be removed. Now, let us understand the concept of subtotal. Subtotal allows us to create groups and have a subtotal for each group. Let us understand this by taking an example. For the following dataset, we can find the total per student by grouping on students and adding their marks. Now, let us select the data we need to group by and subtotal. Click on Subtotal under Data tab. Now click on the column to which the sum function has to be applied. The subtotaling provides control to group and shows subtotals per student. Now, let us understand what the text-to-column function does in Excel. Text-to-column chart is used to convert raw text into columns in an Excel sheet. Now, let us learn how to achieve text-to-column through an example. Consider the following raw text. Here, the information such as name, age, address, phone number, and the university is provided in the raw text form. Let us learn how to put this into a column in Excel. First, open the Excel file and paste the raw content into it. Next, choose column A in the sheet. Go to the Data tab in the header and click on the Text to Columns. Next, in the dialog box, choose the delimited option, as our data is delimited by commas. Hit Next to go to the next step. The next step is to choose the delimiter. The different delimiters can be tab, semicolon, comma, space, or any others. Since the elements in the raw text are separated by commas, we will choose a comma. Click Next to go to the next step. The text-to-column function considers the elements separated by the delimiters, in this case, the commas, as separate entities, and puts each element in a box in an Excel sheet as shown. Now, let us understand what the text-to-column function does in Excel. Text-to-column chart is used to convert raw text into column sheet. Go to the Data tab in the header and click on the Text to Columns. Next, in the dialog box, choose the delimited option, as our data is delimited by commas. Hit Next to go to the next step. Box in an Excel sheet is shown. In this video, we will learn about removing duplicates. First, let us learn what a duplicate is. Duplicate refers to a copy of the original. So, in order to prevent errors, we have to remove duplicates. In any data analytics work, there will always be cases where we would get duplicates in different columns. Excel is very handy in removing duplicates in the data. Duplicates can occur in data and cause errors in analytics. Duplicates occur when there is an incorrect submission of user data multiple times. When there is a missing validation for duplication in the dataset. Duplicates occur when we merge multiple data sources using joins. And also when data is copy-pasted multiple times. When duplicates are removed using Excel, we can choose a single column or multiple columns to check the data. Let us consider an example to understand it. Choose the column with a set of rows to remove duplicates. Here, you can see that there are many duplicates in this column. Let us select the entire column. After selecting it, click on Data, then move your cursor to the rightmost side of the data panel, and then click on Remove Duplicates. After selecting this option, a pop-up will appear. Since the required column is selected, all you have to do is select OK and proceed. Finally, you can see that all the duplicates are removed. Let us consider the following dataset as an example for removing duplicates with multiple columns. Here, there are two entries for math subject under the same name Albert Dane. When removing duplicates for this, only the first row is retained. Let us choose the data to remove duplicates. Now, click on Remove Duplicates from the Data tab. A pop-up will occur to remove duplicates. Now, choose the columns where duplicates need to be checked. Once it is checked, click on OK. Another pop-up will appear which notifies that one duplicate value was found and removed. Also, 3 unique values remain. This will be the final dataset. In this video, we will learn about data validation. The data in Excel can be validated using some rules set in data validation dialog. Let us understand data validation by considering an example. Choose the cell or a group of cells to validate and click on Data Validation under Data tab. It is important to remember that the validation applies to new data entered in the cells where rules are placed. Existing data is not validated. After clicking on the data validation, a pop-up appears regarding the validation criteria. The following validations are possible. Any value allows any alphanumeric value in the cells. Now let us learn about whole number. This validation criteria allows whole numbers and a set of rules, including a range of minimum and maximum to be set. Now let us know about list. List allows only a list of values specified in a range of cells or written manually in the source input box. Now let us learn about date. This validation criteria allows only dates and a set of rules, including a range of minimum and maximum to be set. Let us now learn about time. This validation criteria allows only time values and a set of rules, including a range of minimum and maximum to be set. Let us now learn about text length. In this criteria, only text is permitted within the specified length and a set of rules on the length to be set. Finally, let us know about custom. In this criteria, custom rules on data can be set. Let's recall what we have learned in this lesson. Michael now understands the different operations performed in Excel for data cleaning and preparation. He learned that the main functions of Excel for cleaning data are sort and filter, group by, and ungroup by, and remove duplicates. Michael now knows that Excel has different versions and can suit any type of user. He also understands data validation. For example, whole numbers and decimals, date and time, and text length. Hello, and welcome to the lesson. Formatting, conditional formatting, and important functions. In this lesson, we will learn about custom formatting, how to use it, and implement logical, statistical, and mathematical functions. Let's say we need to differentiate the sales value from a given dataset as above target, below target, and met target. As a dataset can be huge and complex, differentiating each value manually would consume a lot of effort and time. Here we can use Excel features such as formatting and conditional formatting, which will enable us to perform this task easily. Formatting, as the name suggests, helps us format the data using different techniques, making the data easy to read in the required format and analyze them. The right formatting technique applied to the worksheets can help users present the data efficiently. Conditional formatting helps us to visually explore and analyze data, detect critical issues, and identify patterns and trends. Conditional formatting helps to add patterns and trends to the raw information using different colors, icons, formulas, etc. Sometimes we also need to perform mathematical operations and calculations within our dataset. In such cases, Excel provides a large number of logical, statistical, and mathematical functions, such as VLOOKUP, HLOOKUP, if, not, rank, quartile, and many more, that can help the users to perform calculations ranging from basic to complex operations. These inbuilt functions help us manage data and perform descriptive statistical analysis. Excel also offers a wide range of important formulas that help perform many common tasks. These formulas may be as simple as basic addition, or could be a complex combination of inbuilt Excel functions. Before going into details, let us start this lesson by defining the objectives of the lesson. In this lesson, we will learn about formatting, conditional formatting, and some of its important functions. Michael has to perform a task that requires him to use formatting and statistical functions in Excel. He needs to understand and utilize Excel for many purposes. To complete the project, he has to learn to use custom formatting to format date and time values, execute logical operations through logical functions, use conditional formatting in Excel, classify various statistical functions, find position and value of required fields using lookup, and reference functions. Let us now look into custom formatting. The worksheets appear more polished and easy to read if proper formatting techniques are applied to it. We can format the cells in Microsoft Excel manually by selecting the font, color, font size, background colors, and borders. We can also use numerous predefined table styles or quick styles to format a table automatically. This is the basic formatting in Excel. If these built-in functions do not meet our needs or display the data in the format that we require, we can create our own custom format. In this topic, we will focus on custom formatting in Excel. Let's say we want to display 1,532,000 as 1.53 m, or the 1st of January 2016 date, with the weekday as the first Friday, January 2016. Here, we can use the custom formatting feature of Excel. Let's see how we can accomplish this in Excel. Now, let's look at an example. In this lesson, we shall consider the following fields from our master table: dates, order ID, product, salesman, region, number of customers, net sales, and profit and loss. Here in the given worksheet, we have a column named net sales. Suppose we want to display the values of net sales in terms of thousands. For example, 7,164 should be displayed as 7.16K. Select the entire column for net sales. Under the Home tab, click the drop-down present in the Numbers panel. Select the option More Number Formats. The Format Cells dialog box appears. From the category list, select the type as Custom. In the Type Text box, enter number, comma, number, 0 decimal, 00, comma, open double quote, capital K, close double quote. Here, number is the digit holder with 1,000 comma separation. Each comma after decimal, 00, indicates divide value by 1,000. The two zeros after decimal point indicate the number of values after decimal places. The K component displays a literal K character to denote thousands. Here we can see the preview in a sample box. The value shown is 6.53K. Finally, click the OK button. The values in column net sales are now displayed in terms of thousands. Now, let us consider another example of date formatting. In the column dates, we have a date value written as 1st Jan, 2012. We want to display it as 1st Sunday, Jan, 2012. First, select the column containing dates. Under the Home tab, click the drop-down present in the Numbers panel. Select the option More Number Formats. The Format Cells dialog box appears. From the category list, select the type as Custom. In the Type text box, enter DD-DDDD-MMM-YY. The first two DDs are the date. The next four, DDDD is for weekday, say Thursday, then MMM is for the month in short form, and YY is for year. We can see in the preview in the sample box, the value shown is 1, Sunday, Jan 12. Finally, click on OK. Thus, the custom formatting helps us in changing the appearance of the cell value according to our needs. Now, let's move on to the next topic, conditional formatting. The worksheet may contain thousands of rows of data. By simply examining the raw information, it would be difficult to see patterns and trends. Conditional formatting helps us visualize data that make worksheets easier to understand. It quickly highlights important information in the spreadsheet by using colors, icons, and data bars. It changes the appearance of one or more cells when the cell value meets certain criteria. To do this, we need to create a conditional formatting rule. For example, a conditional formatting rule can be, if value is greater than 5,000, color the cell yellow. By applying this rule, we are able to quickly see which cells contain values that are greater than 5,000. Let us understand this with the help of examples. Now that we have looked at the definition of conditional formatting, let us look at an example. Consider the given sales table, which depicts the amount of sales done by each salesman. Here, we want to highlight the duplicate order ID values. First, select the order ID column. Click the Home tab. Under the Styles panel, select the option Conditional Formatting. From the drop-down menu, hover the mouse over Highlight Cells Rules and select Duplicate Values. A Duplicate Values dialog box appears. Select the formatting style from the drop-down menu. In our example, we will choose green fill with dark green text. Click OK. Here we can see that the conditional formatting is applied to the column Order ID. Excel highlights all the duplicate cells with green fill and dark green text. We can also explore other options available in conditional formatting, like greater than, less than, between, equal to, text that contains, a date occurring, and top/bottom rules. All these rules work in the similar format. Excel provides predefined styles to quickly apply conditional formatting to our data. They are data bars. Data bars are horizontal bars added to each column, much like a bar graph. Color scales. Color scales change the color of each cell based on its value. Each color scale uses 2 or 3 color gradients. Icon set. Icon sets add specific icons to each cell based on its value. Let us consider another example to explain how icon set rules are used. Consider the given sales table. Here on the basis of the sales amount, we want to apply the icon set rule. If the sales amount is greater than 8,000, then a green arrow should appear in the upward direction. If the sales amount is between 5,000 and 8,000, then show a yellow arrow in the horizontal direction. If the sales amount is less than 5,000, then show a red arrow in the downward direction. To perform conditional formatting, select the desired cells. Click on the Home tab. Under the Styles panel, select the option Conditional Formatting. From the drop-down menu, hover the mouse over the icon set rules and select the first rule. Again, click on Conditional Formatting. Select the option Manage Rules from the drop-down. A Conditional Formatting Rules Manager dialog box appears. Go to Icon Set Rule, and select the 3 icons set rule. Click on Edit Rule, and an Edit Rule Formatting dialog box appears. By default, for 3 icons set rule, Excel uses the 67th percentile and the 33 percentile rule. This means that it shows a green arrow for values greater than 67%, yellow arrows for values between 67 and 33%, and red arrow for values less than 33%. Now let us customize this rule for our criteria. In the Type dropdown, select the option as Number. In the Value reference box, enter value as 8,000 for green color arrow and 5,000 for yellow color arrow. Excel automatically picks the criteria for the red color arrow. Click OK. In the Conditional Formatting Rules Manager window, click OK. Cells which have a value greater than 8,000 have a green arrow in the upward direction. Values between 5K and 8K are highlighted with a yellow arrow, and values less than 5K are highlighted with a red arrow. Let us consider another example for conditional formatting. We can also apply the conditional formatting rule with the help of formulas. Consider the given table, which shows the profit done by each salesman. Here, we want to highlight the rows in the table wherever profit is greater than 4,000. Select the raw data table without any headings. Click on Conditional Formatting. Select the option New Rule from the dropdown. A new Formatting Rule dialog box appears. Under Select Rule Type, select the option Use a Formula to determine which cells to format. Under Format Values reference box, enter the formula as equals if open bracket $H2 greater than 4,000, true, false, close bracket. This will apply formatting to a cell if the profit is greater than 4,000. Click on the Format button from the Format Cells dialog box. Select the Fill tab. From the Color dialog box, select the color as green. Finally, click OK. The conditional formatting is successfully applied to the cells. Here, we can see that the cells with the profit greater than 4,000 are highlighted with the green color. Let's move on to the next topic, logical functions. Logical functions evaluate a cell or cells for a criteria and return a Boolean value, true or false. In this topic, we will cover various logical functions like if, and, or, not, true, false. Consider the given sales table. Here on the basis of the sales amount, we want to determine the commission percentage of each salesman. Following is the criteria. If net sales greater than or equal to 10,000, set commission as 5%. If net sales greater than or equal to 5,000 and less than or equal to 10,000, set commission as 2.5%. If net sales less than 5,000, set commission as 1.5%. This is a common condition where we're required to create a between formula that picks all values between the two given values. In such conditions, we use if with the and function. Let's write the formula in cell I5. Like any other formula, we will start with the equal sign, then type the function name, that is if, and then type in open parentheses. The first parameter we need to pass is a logical test. Here, the logical test is if sales cell G5 greater than or equal to 10,000, assign the value as 5%. Then we will pass the second logical test. Here we will use in function. If open bracket and open bracket sale, cell G5 greater than or equal to 5,000, cell G5 less than or equal to 10,000, assigned value is 2.5%. In the else parameter, we will type 1.5%. This means that if the first two cases become false, then the formula will assign the value 1.5. Finally, close the two braces for the two ifs. Thus Excel returns, the result is 2.5% for cell G5. Now drag the formula with the help of the fill handle. We can see the results for the other cells as well. The OR function returns true if any of the conditions are true, and returns false if all of the conditions are false. In the given table, we are required to assign performance remarks for each salesman as per the scaling table. In the scaling table, we have the criteria that if net sales is greater than 10,000 or profit is greater than 5,000, set remarks as good, else set remark as needs improvement. Let's write the formula using if and or to check sales and maximum sales in cell J5. So our formula becomes equals if open bracket or open bracket G5 greater than 10,000, H5 greater than or equal to 5,000, double quote, good double quote, double quote, need improvement, double quote, close bracket. Let's drag this formula across the cells with the help of the fill handle. This formula returns true if any of the conditions is true. Thus in the given example, the cell J9 returns good, even if profit is less than 5,000. Our next function is true/false. True/false returns true and false respectively if we write them in any cell. The not function reverses the result of the function. If result is true, it returns false, else true. Let's write the formula as equal, not open brackets K5 close bracket in cell L5. This returns the result as false. Let us now study the different lookup and reference functions used in Excel, such as VLOOKUP, HLOOKUP, match, index, and offset function. The VLOOKUP function lets us search for specific information in the current worksheet. Say we have a list of students with marks. We can search for the marks of a specific student. If our table is in horizontal format and we want to determine a specific value, then we use the HLOOKUP function. Now, let's understand the VLOOKUP function. Consider the extract from our master sales table. The table depicts sales information based on order ID, products sold, salesman, and net sales. Now we want to determine the net sales corresponding to order ID 1, 1, 2, 1. Let's understand how we can accomplish this using the VLOOKUP function. Note that the VLOOKUP function is only used for vertical tables. Let's use cell I2 to add the formula. Like any other formula, we will start with the equal sign, then type our function name VLOOKUP, and then type an open parentheses. Now we will add the arguments. The first argument is lookup value. Lookup value corresponds to the value or item we are searching for. So in our example, it will be order ID 1, 1, 2, 1, cell H2. The second argument is table array. Select the column order ID to net sales. Table array is the cell range that contains the data. In this example, our data is in cell B2 to E40. The third argument is called column index number. The column index number is the column number in which we are looking for information. Here in our table array, net sales are the fourth column. So our third argument will be 4. The fourth argument is range lookup. This value corresponds. If we are looking for approximate matches or not, and can have value either true or false, true denotes the approximate match, and false denotes the exact match. Here, we will pass false. Finally close the parentheses. So our function has the form equal VLOOKUP open bracket, H2, comma, B2, colon, E40, comma, 4, comma, false, close bracket. We can see that the function returns the value as 2, 2, 7, 7. Note that the VLOOKUP function works from left to right. That means the lookup value should always be present in the leftmost column of our table array. Let us move on to the next topic, HLOOKUP function. If our table is in horizontal format and we want to determine a specific value, then we use the HLOOKUP function. Consider the given table. Let's write the formula in cell I4. We will start with the equal sign, then type our function, name, HLOOKUP, and then type open parentheses. The first argument is the lookup value. So in our example, it will be order ID equals 1, 1, 2, 1, cell H4. The second argument is table array. In this example, our data is in cell G8 to AS11. The third argument is row index number. Here in our table array, net sales is the fourth row. So our third argument will be 4. The fourth argument is range lookup. Here we will pass false, finally close the parentheses. So our function has the form equals HLOOKUP. Open bracket, H4, comma, G8, colon, A, S11, comma 4, comma false, close bracket. The function returns the value to 2, 2, 7, 7. Note that the HLOOKUP function works from left to right. That means the lookup value should always be in the topmost row of your table array. Moving on, we have match function. The match function searches for a specified value in an item in a single-dimensional array, and then returns the relative position of that item in the array. Let us understand its functioning with the help of an example. Consider the given sales table shown. Here we want to determine the position of the corresponding date in the original table. So let's write the formula in cell E5. Type equals sign, then type the function name, match, and open parentheses. The first argument is the lookup value. So in our example, it will be the date in cell B5. The second argument is lookup array. The lookup array is a range of cells that contains the value we are searching for. In this example, we will select the cells B17, 2, B1, 3, 4, 2. The third argument is match type. A match type can be either -1, 0, or 1. The value should be 1 if we want to find the largest value less than or equal to the lookup value. The value should be 0 if we want to find the first value exactly equal to the lookup value. The value should be -1 if we want to find the smallest value greater than or equal to lookup value. Here, we will pass the match type as 0 as we require an exact match. Finally close the parentheses. So our function should look like match, open bracket, B5, comma, $B, $17, colon, $B, $1, 3, 4, 2, comma, 0, close bracket. This returns the value as 3. Now we can drag the formula across cells with the help of the fill handle. Similarly, we can use the match formula in cell E3 to determine the position of the shown field name, cell C3, in range B17 to I17. For example, net sales is at 7th position in the range B17 to I17. Let's write the function in cell E3. Write the formula as equal sign, match, and open parentheses. In the first argument, select cell C3. For second argument, select cells B17 to I17. Pass third argument as 0. Finally close the parentheses. So our function looks like equal match, open bracket, C3, comma, $B, $17, colon, $I, $17, comma, 0, close bracket. So for the profit-loss field, the value returned is 8. And for net sale, the value returned is 7. Now, let us learn about index and offset function. The index function returns value from a specified position in a specific column of a list. Suppose we want to determine the value of the field mentioned in cell C3 from the sales table on a specified date. The table should dynamically fetch the value if the value of the cell C3 is changed. If we enter profit-loss, formulas should fetch the profit-loss value for the specified date. If we write net sales and cell C3, then the formula should fetch net sales value for a specified date. So let's use the index function to determine the value in this worksheet. Select cell C5, write formula as equal sign index, and open parentheses. The first argument is the array. For our example, enter B17, colon I1, 3, 4, 2. The second argument is the row num. This corresponds to the row number that has the value we want to return. Here we will enter E5, which denotes the required date. The third argument is column number. This corresponds to the column number that has the value we want to return. Here we will enter E3, which denotes the position of the field name in cell C3 in the table. Finally, close the parentheses. Thus our formula returns the value as 6,528, based on the position at cell Z5. This is the net sales value on the date, the 2nd of January. Now drag the formula with the fill handle to the other cells as well. The offset function returns a reference to a range, that is the offset number of the rows and columns from another ranger cell. Now let's understand how to use it. Select cell D5, write formula is equals sign offset, and open parentheses. The first argument is the reference. This denotes the starting range from which the offset will be applied. For our example, we will select the reference cell as B17. The second argument is the rows. This denotes the number of rows to apply as the offset to the reference. This can be a positive or a negative number. So for our example, we will enter E5 minus 1. Here we are subtracting 1 to match the number of rows, which have the value and the offset from the reference cell. The third argument is the cols. This corresponds to the column number that has the value we want to return here. We will enter E3, which denotes a position at the field name, and subtract by 1 to match with the offset referencing. Finally, close the parentheses. The function returns the value based on the position of date from cell B5 and field from cell C3. Now drag the formula across the cells with the help of the fill handle. If we enter a profit loss, the formula should fetch the profit loss value for the specified date. Let us move on to the next topic, statistical functions. A variety of statistical functions are available in Excel to perform calculations ranging from basic function, mean, median, and mode, to more composite distribution and test, binomial, or chi-square. In this lesson, we will cover various statistical functions like sum-ifs, count-ifs, percentile, quartiles, standard deviation, and median. Now, let us learn about sum-ifs function. Sum-ifs and count-ifs are the most frequently used functions in Excel. These functions allow us to perform count and sum based on one or more criteria. The sum-ifs function calculates the sum of cells based on certain criteria. Let's understand how to use the function with the help of an example. Consider the given sales table. Say we want to determine the net sales done by salesman Justin. Here we will use the sum-ifs function to calculate net sales. So let's write the formula in cell N4. Type equals sign, then type the function name, sum-ifs, and then type an open parentheses. The first argument is the sum range. This is the input range that contains the required data. So, in our example, we will select cells H3 to H1328. The second argument is the criteria range. This denotes the range that contains the required criteria. Here, we'll pass the range that holds salesman's name cells, E3 to E1328. The third argument is criteria. This corresponds to our required criteria. We only require net sales of the salesman, Justin. So, we will select cell M4. Finally, close the parenthesis. Note that we can pass multiple criteria in this function. The function returns the net sales done by Justin. Let us look at an example of count-ifs function. Count-ifs function is similar to the sum-ifs function. It counts the number of cells in a given range when certain criteria is met. Say in the given sales table, we want to determine the total number of sales for net sales greater than 8,000. To determine the count, we will use the count-ifs function. So let's write the formula in cell N5. Type the equals sign, then type the function name count-ifs, and then type an open parentheses. The first argument is the criteria range 1. This denotes the range that contains the required criteria. Here, we will pass the cells containing net sales H3 to H1328. The second argument is criteria 1. This corresponds to our required criteria. We only require entries with net sales greater than 8,000, so we will enter greater than 8,000. Finally, close the parentheses. Note that the function allows you to enter multiple criteria. So, M5 reflects the total number of sales as 445 for net sales greater than 8,000. In this topic, we will learn how to use the functions percentile and quartiles in Excel. Consider the given sales table. Let's see how to use the percentile function on net sales to find its 40th percentile. Select the cell N6, write the formula as equals sign percentile, open bracket. Select the column net sales H3. 2. H1328 is our first argument. Pass the second argument as 0.4 in order to find the 40th percentile. This returns the result 5,220. This means that 40% of the net sales is less than or equal to 5,220. The next function is quartile. Quartile function depicts the results for the first, second, third, and fourth quartile. Say we want to find the total number of sales, which are less than or equal to 25%. Let's use the quartile function to calculate this. Select cell N7 to write the formula. Type equals sign function name is quartile and open braces. Select net sales column. H3 to H1328 is the first argument. Type 1 is the second argument. The second argument must be a number between 0 and 4. The function returns the value as 3,822, which means that 25% of the sale is less than or equal to 3,822. Note that here we can use the percentile function to perform the same task. The function percentile H3 to H1328, 0.25 gives us the same result. It's up to us which function we would like to use for the quartiles. In this topic, we will learn about standard deviation, median, and rank function. Excel has a function to calculate sample standard deviations, STDEV. Standard deviation determines how dispersed the data is from the mean. Say we want to calculate the standard deviation for a number of customers. So write the formula in cell N8 as equals the function name, STDEV, open braces. Select number of customers columns as its argument. The function returns a result, 1.4. The median function returns the value from the range. For example, we want to find the mid value for net sales to calculate median in cell N9. Write the formula as equals sign the function name median, then open braces, select net sales column as its argument. This calculates the mid-value of net sales as 6,192. Rank function is used to compare a number from the rest of the numbers in the list in any order, whether ascending or descending. This function returns the rank of the number relative to the other values in the list. Let's use rank function in cell J4 to calculate rank on the basis of net sales. Select cell J4 and write the formula as equals sign, then type the function name rank, and then type an open parentheses. The first argument is the number. This is the value whose rank we are required to calculate. Here we will pass the argument, cell H4. The second argument is ref. This corresponds to the array or reference list. Here we will select the column, net sales. That is cells H4 to H1328. The third number is order. This specifies how to rank the number. 0 means descending order, and 1 denotes ascending order. This argument is optional. If we don't pass any argument, Excel automatically takes the argument 0. Here we will pass the 0. Finally close the parentheses. Here we can see that Excel has determined the rank for net sales, 7,164, as 553. Finally, we can drag the formula and can see the rank for the other cells based on net sales. Now that you have learned how to perform custom and conditional formatting, use logical, statistical, and lookup functions, let's do a small exercise to reinforce the concepts learned. We will provide you a step-by-step assistance to do this exercise. Let's start working on this together. Consider the given shared stock price data of various companies across different years. You are required to calculate the stock price in cell C6 for company Infosys for the year 2012. Use offset and match function. Let us consider the given data of stock prices of various companies across different years. Now, calculate the stock price of cell C6 for Infosys in the year 2012 using offset and match functions. To do this, let us first open the file stockprices.xlsx. Now, select cell C6. In the next step, type equals offset in the cell to get Infosys price in 2012. Next, select B9 as the first parameter. Now, type match. B4. B10 to B14 as the second parameter. Finally, type match. C4. C9 to G9 as the third parameter. Let's recall what we have learned in this lesson. Michael now understands the different formatting operations and logical functions performed in Excel. He learned that conditional formatting highlights important information in a spreadsheet by using colors, icons, and data bars, and that logical functions of Excel evaluates a cell for certain criteria and returns a Boolean value as true or false. Michael now knows that Excel has different versions and can suit any type of user. He also understands that the VLOOKUP and HLOOKUP functions search for specific information in the current working sheet. Let's recall what we have learned so far. Analytics plays a critical role in business, as well as a variety of other industries like finance, sports, government, etc. The study of analytics often involves historical data to look for potential trends of the past to understand the effects of certain decisions and evaluate the performance of the businesses. There are 4 types of analytics, namely descriptive, which explains what has happened, predictive, which depicts what could happen, diagnostic, which determines why it happened, and prescriptive, which talks about what should happen. Business analytics can be divided into several types, such as customer analytics, financial analytics, performance analytics, and risk analytics. The sort and filter functionalities are available in Excel to order or filter the data for further analysis. Group by functionality in Excel allows us to show necessary data for easy viewing and analysis. The ungroup option allows us to remove the groups created by group. While removing duplicates, we can choose single or multiple columns to check the data. Data validation, on the other hand, applies only to new data entered in the cells where rules are placed. Formatting helps format the data using different techniques, making the data easy to read and analyze. Formatting techniques apply to the worksheet to help users present data efficiently, whereas conditional formatting helps the users to apply formatting to specific cells so that the data makes more sense. Excel provides many logical, statistical, and mathematical functions, such as VLOOKUP, HLOOKUP, quartile, etc. Logical functions evaluate a cell or cells for certain criteria and return a Boolean value as true or false. The statistical and mathematical functions help users manage data, perform descriptive statistical analysis, and perform calculations ranging from basic to complex scenarios. The reference functions index, match, and offset return the relative position and value in a single-dimensional array. Hello, and welcome to the lesson, Analyzing Data with Pivot Tables. Being able to analyze all the data in our worksheet can help us make better business decisions. But sometimes it's hard to know where to start, especially when we have a lot of data. Suppose we want to determine the net sales in each region in the given table. Analyzing this manually could be difficult as region appears in multiple rows, and we need to total them individually. We can also determine net sales using Excel's built-in formulas, a task that could become quite time-consuming. Here, a pivot table comes into the picture and helps extract key information from this large detailed dataset. A pivot table is an incredibly powerful tool that makes it easy to summarize, analyze, explore, and present the data. A pivot table makes life easy, giving us insights into the data and allowing us to experiment with it to discover new trends and patterns. It can instantly calculate and summarize data in a way that's both easy to read and manipulate. One can easily design a pivot table by simply dragging and dropping relevant information into the appropriate boxes. In this lesson, we will learn about pivot tables, how to create them in Excel, and how to design them according to requirements. Before going into details, let us start this lesson by defining its objectives. In this lesson, we will learn about pivot table and analyze data with pivot table. Michael has been assigned to create a report that requires him to use the pivot table tool in Excel. To complete the project, he has to learn to use pivot tables and create them in Excel. Group 2 different data types in a pivot table. Create and evaluate the summarized values in a pivot table. Illustrate the use of calculated field and calculated item. And design interactive pivot table using a slicer. Now, let us learn about pivot tables. Pivot tables are very useful and powerful features of Excel. They can be used to summarize, analyze, explore, and present data in tabular form. Consider the given sample sales data, which includes the following data fields: dates, order ID, product, salesman, region, number of customers, net sales, and profit and loss. Let's say we want to determine the net sales done by the salesman in each region. Analyzing this manually would be time-consuming and difficult, as the data for each region appears on multiple rows, and we would need a total of all different orders individually. Here, pivot table comes into play and becomes a lifesaver. This data can be analyzed easily by creating a pivot table. The feature allows us to calculate and summarize data instantly, which is both easy to read and manipulate. Once we've created a pivot table, we can quickly pivot or reorganize data to answer different questions. Let us now understand how to create pivot tables in Excel. Now, let us look at how to create a pivot table. To create a pivot table in Excel, select the cells containing the data we want to use. Click the Insert tab and select the Pivot Table option. The Create Pivot Table dialog box appears. Under Table Range, Reference Box Excel automatically selects the data range that we want to use to create the pivot table. There is also an option asking for the placement of the pivot table. This feature allows us to decide whether we would like to place the pivot table in a new worksheet or at a particular location in the existing worksheet. Here, we will select a new worksheet and click OK. After clicking OK, Excel creates a new workbook with a blank pivot table and a pivot table fields box on the right side of the workbook. If we are not able to see the pivot table fields box, then right-click the pivot table and select the Show Fields list. The pivot table field list box contains two sections, namely a field section and an area section. The field section allows us to pick the fields required to create a pivot table. Area section allows us to arrange the fields the way we want them to be displayed in the pivot table. Now let's create a pivot table to determine the region-wise net sales within the pivot table field list tasks pane. First, drag the salesman field into the area marked rows. Then drag the region field into the area marked as columns. Lastly, drag the net sales field into the area marked as calculated values. Here, we can see that the pivot table is populated with the net sales done by the salesman in each region. Like any normal spreadsheet, any type of number formatting can be applied. Now, if we would like to see the total number of sales instead of the net sales, then we should change the sum of sales function to the count of sales. To change this function, right-click the Value field and click the Value field settings. In Summarize Values field by dialog box, select Count function and click OK. By using this function, we can easily determine the total number of sales done by each salesman. Let's now study the next topic, grouping in pivot table. It is often useful to group the fields in the pivot table by the header values. Grouping data in a pivot table allows us to group the data for any field added as a row or column. Excel can do this automatically for numeric values, including dates and time. Let us understand this concept in detail with the help of an example. Let us now look at an example for grouping pivot tables in Excel. Consider the same sample sales data used earlier. Let's say we would like to determine the month-wise and year-wise net sales. To do this, we will use the group feature. First, let us create the pivot table showing the sales figure for each date. Select the required data. First, click on A1 and press Ctrl-Shift-Right. Now press Ctrl-Shift-Down arrow key. In the Insert tab, click the Pivot Table command. The Create Pivot Table dialog box appears. Under Table Range Reference box, Excel automatically selects the data range, then click OK. To create a pivot table for sales representing each date, drag the Dates field in the Rows area and the Net Sales field in Calculated Values area. Here, a pivot table is created, which shows the date-wise sales figures. Now to group the data month-wise, right-click the leftmost column of the pivot table, representing the dates, and select the option Group. The Grouping dialog box appears. In this dialog box, under By Section, select Months and click OK. Now, the data is grouped month-wise. Now group the data year-wise. Once again right-click the leftmost column of the pivot table, representing the dates, and select the option Group. A grouping dialog box appears. In this dialog box, under By Section, select Years, and click OK. You can now see that the data in this pivot table has been grouped month-wise and year-wise. Let us take another example. We will use the same sample sales data. Now we need to create a pivot table that groups the sales amount in an interval of 1,000 sales items according to the number of sales. Let's begin by creating the pivot table. Select the required data. First, click on A1 and press Ctrl, Shift, right. Now press Ctrl, Shift, down arrow key. In the Insert tab, click the Pivot Table command. The Create the Pivot Table in the dialog box appears. Under the table range pivot table in the dialog automatically selects the data range reference. Click OK. Excel automatically selects the data range. Then click OK. To create a pivot table, drag net sales field in the rows area. And again the calculated field's value. To see the total number of sales, we need to change the sum function to the count function. Right-click the value field, and then click the value field setting. In Summarize by dialog box, select Count function, and click OK. The pivot table created portrays the number of sales according to the sales amount. To group this data, right-click the row field, and select the option Group. A grouping dialog box appears. In this dialog box, enter the start, end, and interval values. Here we will enter the start value as 1300, the end value is 15,000, and the interval value is 1000. This will group the sales amount, beginning with the class interval 1300 to 2299, up to 15,300. Thus the grouping feature helps us create a table with class intervals and the number of values in each class intervals. Let us now move on to the next topic, custom calculation. Sometimes there's a need to change the way the values are displayed in the pivot table. For example, we might want to display the value in terms of a percentage instead of a total, or average the values instead of summing them. To see how this can be done in Excel, let's consider the pivot table we created earlier. Here, the pivot table depicts the net sales done by the salesman in each region. Now we need to visualize the values as a percentage, or depict the net sales in the region as a percentage of the grand total. To do this, right-click in the Value Area section, and select Show Values as option. Select the option Percentage of Grand Total from the list displayed. The pivot table will change the values into the percentage of the grand total. In this way, we can easily check the percentage values of the sales in each region. There are different options available in Show Values as options like percentage of column total, percentage of row total, or difference from value and so on, which can be used according to our requirement. Next, we will learn about calculated field and calculated item features. Once we have created a pivot table, we can add calculated fields and calculated items in it. These features help us enhance the results by allowing us to write our own formulas. This functionality helps create a new field in the table that performs the calculations based on other pivot fields. Let us understand how to use these fields with the help of an example. Let us now look at an example of calculated field. Consider the given pivot table. Here, we need to distribute the incentives to salespeople based on their sales amount. If sales are more than 1,200,000, we should give 0.5% of net sales as an incentive, else no incentive shall be given. To perform this task, an extra field needs to be added to the current pivot table. This is done with the help of a calculated field feature. To add a new field to the pivot table, select a cell in the pivot table. Click the Analyze tab, select Field, Item and Sets, and then select the option Calculated Field. An Insert Calculated Field dialog box appears. Type the name of the calculated field as incentive. Then write the logical formula in the formula text box. Type equal, if, and open bracket. Then type sales after that. Type greater than symbol. Then type 1,200,000, comma, sales and add multiply symbol, 0.05. Finally add comma and type 0 by dragging sales field from the fields box. Then click OK. This will create a new field named incentive in the field list. In this way, we can create a new calculated field in the pivot table. Now, let us look into calculated item. We can also add one or more calculated items in the pivot table field apart from the existing items. Calculated items are used to perform calculations between items within the fields. Consider the given pivot table. Here we want to compare the sales within different regions. Let's say we want to compare the sales for the following regions simultaneously: North versus West, West versus Middle, Middle versus North. This can be done easily by inserting the calculated items in the pivot table. In the Analyze tab, click Field, Item, and Sets, and then select the calculated item. An Insert Calculated Item dialog box appears. Here you are required to create 3 new columns for the region. For that, select Region in the Field section. In the Name text box, enter the name as North versus West. Then write the logical formula in the formula text box. Take the formula as equals North by West by dragging the North and West column into the formula's text box. Repeat the steps in the other comparisons as well. That is West versus Middle. And Middle versus North. After completing this action, you will see that 3 new columns have been inserted into the pivot table to perform the comparative analysis between the regions. Now, let us move on to the topic slicer. Sometimes, depending on the need and the reason for the data analysis, the focus is required on just a specific section of the data. The filters feature available in Excel makes it quite easy to narrow down the data in the pivot table, extracting the required information. In this topic, we will study about the easy-to-use filtering components, known as slicers. Slicers contain a set of buttons, which make filtering data in pivot tables easier and quicker. We do not have to open the drop-down box list to find the items we want to filter. We can create slices for any field and can filter the pivot table by selecting the type of data we want. Let us learn how to create a slicer. Consider the given pivot table. Suppose we want to analyze the sales for different regions and present the net sales done by each salesman in the form of a pivot report. You can do this with the help of slicers. Slicers can help us analyze the data quickly for 2 different regions. Let us now add slicers for the region field. To add a slicer, select any cell in the pivot table. From the Analysis tab under the Filter section, click the command Insert Slicer. An Insert Slicer dialog box appears. Select the desired field. In our example, we will use the Region checkbox and click OK. You can see the slicer appears right next to the pivot table. Each selected item is highlighted in blue. In this example, the slicer contains a list of all regions. Just like filters, only selected items are used in the pivot table. The pivot table will instantly reflect the changes when you select or deselect the items. We can also select multiple items from a slicer by pressing and holding the Control key on the keyboard. One of the best things about Slicer is it can easily drill the available data. When we select or deselect items, the pivot table instantly reflects the changes. Now that you have learned how to create pivot tables, perform custom calculations, and apply filters to it, let us do a small exercise to reinforce the concepts. We will provide you step-by-step assistance to do this exercise. Let's start working on this together. Consider the given organization sales data, which includes the following data fields: transaction ID, location, date item, salesman, units sold, and amount. You are the sales manager of an operational team in the organization. You're required to create a pivot table, which depicts the following: the net quarterly sales at each location, and the average number of sales at different locations. Also add a calculated field that depicts the incentive for each salesman. The incentive of 5% should be given to a salesman if the sales amount is greater than $200, else no incentive is given. Finally, add a slicer to filter the data location-wise. Let us consider the given data to create a pivot table which depicts the net quarterly sales of each location and the average number of sales at different locations. In order to do this, add a calculated field that depicts the incentive of each salesman. If the sales amount is greater than $200, an incentive of 5% should be given to the salesman, otherwise no incentive is given. Let us look at the steps involved in creating this pivot table. The first step is to open the file pivottable.xlsx. Next, choose the complete data. Now click on Insert and then click on Pivot Table. In the field chooser, add dates to rows. Next, add net sales to values. Now add location to columns. After adding it, right-click on dates in the pivot table. Choose Group and select years and quarters together. Now click on OK. In the field chooser, add net sales to values. Now, click on the net sales values and drag it to the list of summarized value field by list. Then, click on the pivot table. Click Analyze and Insert Slicer. Click on Location on the field list. The field slicer allows the user to filter the data. Now, click on the pivot table. Click on Analyze tab. Click on Fields, Items and Sets. Now, choose Insert Calculated Field. Then, type field name as incentive. And the last step is to type is equal to if net sales greater than 200, 0.05 times of net sales, 0 in the formula box. Let's recall what we learned in this lesson. Michael can now analyze data using the pivot table in Excel. He learned that pivot tables are used to summarize, analyze, explore, and present the data in the form of a table. Grouping data in a pivot table can help to show a subset of data to be analyzed. In a pivot table, summary functions and value fields can be used to combine values from the underlying source data. Formulas can be created in the calculated fields and calculated items. And finally, he learned that slicers are easy to use filtering components that contain a set of buttons used to quickly filter the data in a pivot table. Hello, and welcome to the lesson Dashboarding. This lesson will explain how to create and format different types of charts, such as thermometer and Pareto charts. It will also cover the importance of interactive charts and form controls, such as combo box, checkbox, and radio buttons. Let's say a large automobile component manufacturer is looking for a detailed analysis of the profit and sales across various regions in a product-wise manner. The dataset is huge and scattered across the regions. Collating all these datasets and analyzing the profit and sales value across the various regions is a difficult task. Using dashboards, the data visualization tool of Excel, it is easy to create a detailed analysis report. These dashboard reports will provide insights and alert us in case of negative trends or projections for profit sales in specific regions, which can then be used to develop future strategy. Dashboards are highly effective in validating the effectiveness of the matrix captured over time and bringing out the leading trends. Dashboards help consolidate and organize these metrics through a summary. Let us start this lesson by defining its objectives. Hello, and welcome to the lesson Dashboarding. This lesson will explain how to create and format different types of charts, such as thermometer and Pareto charts. It will also cover the importance of interactive charts and form controls, such as combo box, checkbox, and radio buttons. Let's say a large automobile component manufacturer is looking for a detailed analysis of the profit and sales across various regions in a product-wise manner. The dataset is huge and scattered across the regions. Collating all these datasets and analyzing the profit and sales value across the various regions is a difficult task. Using dashboards, the data visualization tool of Excel, it is easy to create a detailed analysis report. These dashboard reports will provide insights and alert us in case of negative trends or projections for profit sales in specific regions, which can then be used to develop future strategy. Dashboards are highly effective in validating the effectiveness of the matrix captured over time and bringing out the leading trends. Dashboards help consolidate and organize these metrics through a summary. Let us start this lesson by defining its objectives. In this lesson, we will learn about dashboarding using Excel. Michael needs to create dashboards and design interactive charts in Excel. To complete this task, he has to learn to define dashboards and classify the principles of dashboard design, create interactive charts and format them, construct an interactive dashboard, use form controls such as combo box, checkbox, and radio button. Let us learn about dashboard. When it comes to large or complex data sources, we might face difficulties in reviewing the detailed views. Well, in order to see the views clearly, we can create an interactive dashboard to limit the data shown. A dashboard is generally defined as a real-time tool, which is an easy-to-read user interface showing a graphical presentation of the data. It is an efficient way to extract data into actionable insights. Dashboard reports are very popular these days. They help the reader to quickly analyze the data and take action accordingly. An appropriately designed dashboard can quicken the decision-making process, provide better coordination for your organization's efforts, and record the performance outcome. Moving on, let us look into principles of great dashboard design. What are the principles of a great dashboard? This is a very tricky question, as it's easier to recognize an exceptional dashboard design rather than describing it. A good business dashboard is an indispensable tool when designed appropriately. Unfortunately, most of the dashboards are overstuffed, sluggish, and ultimately too hard to use. It's all about presenting the right datasets in a seamless and understandable manner. Now we will be learning a few key points which we need to consider before designing a dashboard. 1. Who is my audience? It's important to show the right data to the right audience. We need to take care of the target audience for whom we are designing the dashboard. For example, if we are designing it for the managerial level, we should include associate-level analysis. But if we're designing it for the CEO level, we should include analysis for the business level as well. 2. What value will the dashboard add? We need to take care of the KPIs or key performance indicators we add to our dashboard. In the below screenshot, we have a profit and sales data region-wise, product-wise, and salesman-wise, so management can easily see the trend and take relevant actions accordingly. 3. What type of dashboard are we creating? As per our target audience, we can always decide first which type of dashboard we are planning to design. There are commonly 3 types of dashboards: operational, analytical, and strategical. Number 4. No scrolling. It is best if we are able to see everything at once. We should try to avoid fragmenting our data by having to scroll. Number 5. Allow drill-down capabilities within dashboards. It's good to add form controls in a dashboard, like a combo box checkbox, etc., so the user can easily drill down the data and see the result. Number 6. Include actionable information. We should always try to include information which prompts the user to initiate an action. Let us now learn how to create charts in Excel. The worksheet may contain thousands of rows of data. By simply examining the raw information, it would be difficult to see patterns and trends. Charts allow us to represent the data graphically, making it easy to analyze comparisons and trends. In Excel, a number of chart types are available like line column, bar pie, etc. The selection of the right chart type depends on what your data represents and how we want to visualize it. We can choose the chart type that best fits our data. Column charts are used when we want to work with a variety of data and perform comparisons between them. Line charts are used to depict trends in data and illustrate its progression over time. Pie charts compare the proportion of each category, where each category is shown as a slice of the pie. Bar charts are used to compare data by displaying values using horizontal columns. Creating a chart is very easy in Excel. Consider the given sales data. This table shows the net sales and the profit loss for each salesman. The data in this table has been extracted from our master table by creating a pivot table, considering the field salesman, net sales, and profit and loss. To create a chart, perform the given steps. Select the cells whose data we want to display in our table. Here, we will select the cells B6 to D13. Click the Insert tab. Under Charts panel, select the chart type we want to create. Here we will click on Column Chart from the drop-down menu. Select 2D Clustered Column Chart. The column chart appears on the worksheet. This chart depicts the net sales and profit and loss done by each salesman in the form of columns. We can easily switch between different chart types. Suppose we want to change the column chart for profit and loss to a line chart. Then, select the column chart for profit and loss and right-click on it. And select the option Change Series Chart Type. The Chart Type dialog box appears in the reference box adjoining Profit or Loss. Select the chart type as Line and click OK. The line chart appears for field profit loss. Moving on to the next topic, chart formatting. We can apply special formatting, like changing background colors, adding legends, adding data labels, color, etc., to the charts created at any point in time. When we select a chart in Excel, 2 extra tabs appear in the menu: Design and Format. With the help of these two tabs, we can change the design of the chart by applying any formatting to it. Let's say we want to change the background color of our chart. Select the chart. Click the Format tab. Under Shape Style panel, select Shape Fill option and select the required color. The chart is updated with the new background color. We can also format a specific part of the chart. Let's apply formatting to the vertical and horizontal axis in our chart. Here we will change the maximum value in our vertical axis to 1,500,000. Select the vertical axis, then perform a right-click and select the option Format Axis. In the Format Axis box under Axis Options, set maximum value as 1,500,000. The chart is updated with the new values in the vertical axis. In this topic, we will learn how to create a chart which looks like a thermometer that is a thermometer chart. It is used to represent data when we have an actual value and a target value. This chart shows how much we have achieved from our target. Consider the given sales table. The table depicts the amount of sales done in each month of the year, 2015. Our total yearly target was 10 million, but we were able to achieve a target of 8.6 million sales only. Let us consider a thermometer chart, which depicts how much sales have been achieved compared to the total target. Select the data cell C22. Then, click on Insert tab. Under the Charts panel, select Column Chart. Then click on Clustered Column. A column chart appears on the worksheet. Now we will remove the gap between the vertical axis and the series. Select the column chart. Right-click the bar. And select the option Format Data Series. In the Format Data Series dialog box, select Gap Width as 0%. Lastly, reduce the width of the chart. Now we will fix the vertical axis to 100%. Select the vertical axis on the left. Right-click the axis and select the option Format Axis. In the Format Axis dialog box, set the maximum value as 1 under Axis Options. We can also change the background color of column chart. To change the background color of column, select the column in the chart. Right-click the column and select the option Format Data Series. Select the fill color as red. Right-click the remaining portion of the chart and select the option Format Plot Area. Select the fill color as black. Now we will insert an oval shape and group it with the chart. Click on the Insert tab. Choose the Illustrations panel. Under this panel, click on Shapes. Select the shape oval and draw this shape below the column chart. Let's change the color of the oval to red. Select the oval shape. Click on the Format tab. Under the Shape Format panel, click on Shape Fill. A variety of colors are displayed. Choose the color red. Now, click on Shape Outline and select the color as red. This changes the color of the shape outline. Now, click on Home tab. To group the shape and the chart, select the oval. Using the Control key, select the column chart as well. Right-click the shape and select the option group. Here's the outcome of our work. The thermometer chart is ready. Now, let us learn about Pareto chart. The Pareto chart contains both the column chart and a line graph. In this chart, the line graph represents the cumulative total, and the column chart represents the individual values arranged in descending order. The purpose of the Pareto chart is to highlight the crucial factor among a set of factors. It is used as a basic tool for quality control, as it allows us to easily determine the common problems and issues. Let us consider an example. An online e-commerce business was witnessing a steady decline in profits. Management assumed that the decline in profit was due to customer dissatisfaction with the product they were selling and blamed their supply chain vendor for this problem. So the management decided to do a customer survey to list down the type and frequency of complaints. In the table we have customer complaints, frequency, and cumulative percentage data. We want to create a chart for frequency and cumulative frequency percentage. To create a Pareto chart, select cells from B5 to E15. Click on Insert tab. Under the Charts panel, select Column Chart. From the drop-down menu, select 2D Clustered Column Chart. Now let's create a secondary axis for cumulative frequency. Select the cumulative frequency column. Click on the Format tab under Current Selection Group. Select the option series Cumulative Frequency from the drop-down. Click on Format Selection under Series Options. Select the Secondary Axis Radio button. Now, select the Cumulative Frequency columns. Right-click on it and select the option Change Series Chart Type. In Change Chart Type, click the drop-down next to the Cumulative Frequency percentage. And select the Line Chart. Click OK. This creates a Pareto analysis chart for our data. From the Pareto chart, it's clear that the reasons for the business not running well are payment gateway failure and slow web service. In this example, we have learned how to add a secondary axis to the chart. We can add a secondary axis to our chart when you have different data types. In our current example, we have a data type number for frequency and percentage for cumulative frequency. Now, let us learn about the speedometer chart. You might already be familiar with the speedometer of a vehicle. It shows the minimum and the maximum speeds achievable by a vehicle. There will also be a needle pointing to the current speed. The speedometer chart in Excel performs similar functions. It shows where we are placed with respect to the target. Different milestones can be represented with different colors. Here, 0 to 25%, 25 to 75%, and 75 to 100% are represented by red, yellow, and green bars respectively. As an example, let us take a fundraising status represented by a speedometer chart. If the target value for the fund is $10 million and the current amount raised is $8,699,639, the speedometer chart looks like this. Let's learn how to create this chart. Next, we will learn how to create a speedometer chart. The first step is to create a dataset. Under Values, enter the values 25, 50, 25, and 100, where 25 is the length of the red bar, which starts from 0 and ends at 25. The green bar length is entered next, which is 50. Since we are trying to show the percentage of completion, the maximum value achievable is 100. The total length covered so far is 75. Hence the yellow bar length is 25, which is entered next, and the maximum value achievable is noted down, which is 100. The next step is to enter the pi values for the pointer. First, enter the value that you want the pointer to point at. In this case, it is 87, as 87% of the fund has been raised. The second value is the size of the pointer. If you want a wider pointer, you can enter a value greater than 1. Lastly, the value at the end is calculated based on the formula 200 minus first value. In this case, it will be 200 minus 87, which is 113. Next, click on the Insert tab and Charts group. Click on More Pie Charts. And then, click on Combo in the dialog box. Select chart type for value as donut, and chart type for pie as a pie chart. Select the checkbox to make the pie chart as a secondary axis, and click OK. When the pie chart appears on screen, select Chart Elements and change the chart title, and remove the legend. For the next step, click on the chart, and click on the Format tab. In the current selection group, choose Series Pie. Next, select Format Selection to see the Format Data series. Now, change the angle of the first slice to 271 degrees and click OK. Next, click Ctrl plus right arrow on the keyboard to see Series Pi Point 1 in current selection. Select the No Fill option. Now, let us fill the chart with appropriate colors. First, the needle. Click Ctrl plus right arrow again to see Series Pi Point 2. Change Fill to Solid Fill and Color to Black. Click Ctrl plus right arrow again to see Series Pi Point 3. Choose Series Arction as No Fill Under Fill. Change Series Arctions to Series Values under current selection. Choose Angle of the Slice as 271 in Format Data Series. This step should orient our chart correctly. Now, select the first part and click Ctrl plus right arrow to see Series Value Point 1. Change Fill to Solid Fill and Color to Red in Format Data Point. This step will fill the first tab with red color. Next, select the second tab and click on Ctrl plus right arrow to see Series Value Point 2. Change Fill to Solid Fill and Color to Yellow in Format Data Point. This step will fill the second tab with yellow color. Finally, select the third tab and click on Ctrl plus right arrow to see Series Value Point 3. Change Fill to Solid Fill and Color to Green in Format Data Point. Click on Ctrl plus right arrow to see Series Value Point 4. Change Fill to No Fill. The resulting chart looks like the one shown on the screen. Now, we can add a couple of text boxes to show the needle point and target achieved. Now, let us understand the stacked column chart. The stacked column chart is like a column or bar chart. In this type of chart, multiple y-axis values can be stacked together for the same x-axis values. Different color coding is used for different types of y values, which help to segregate and understand data easily. This chart can be used when we want to have a categorical set of values in x-axis and a set of numerical values in y-axis with different groups. Let us understand this with an example. We can stack the CGPAs of students in different subjects and find the total CGPA using a stacked column chart. This is especially useful to understand the distribution of marks and rankings of students in different subjects. To create a stacked column chart, please follow these steps. Choose the data to include in the chart. Click on Stack 2D Chart under Insert tab. And go to Stack 2D Column and select Stacked Column Chart. The result will look like this. Click on Axes to show the X and Y axes. The main difference between a bar chart and a stacked column chart is the number of dimensions represented. Bar chart holds a categorical value in the x-axis and a set of numerical values in the y-axis. Stacked column chart holds multiple numerical columns in y-axis with different color coding. This is particularly useful when we would like to represent group data with individual data elements in y-axis. Let us understand the concept of funnel chart. The funnel represents a pipe where the input is wider than the output. The funnel chart is very similar to a stacked horizontal column chart. The bars are ordered in accordance with the stages of a process. The name funnel describes that the data flows through a funnel of processes. For instance, we can take the number of defects found in a project in different phases. The defects ideally should reduce as we move to production as the product is being tested in different stages. The funneling of defects is shown in the given funnel chart. To create a funnel chart, choose the data and go to Insert, then click on More Charts and select Funnel Chart. The resultant chart will look like this. Excel automatically groups the count of defects in the decreasing order and displays the phases like a funnel. The difference between a funnel chart and a stacked horizontal bar chart is that in the stacked chart, there is no ordering of numeric values. Whereas in the funnel chart, the values are arranged in decreasing order, and the bars are centered in the plot. Next, we will take a look at the pivot chart. What is a pivot chart? It is a virtual representation of a pivot table. As you might already know, pivot tables are used to create a summary of base data. Let us understand how to create the pivot chart when we have the necessary data. Let's consider the sales figures of various products for different salespeople and locations. First, let's look at the steps to create a pivot table. Press Ctrl+A to select all the data. Click on the Insert tab and then on the Pivot table. Click OK on the dialog for the pivot table that pops up. In the pivot table fields, choose Salesman, Region, and Net Sales. Set columns as Region, rows as Salesman, and values as the sum of net sales. This will be the resulting pivot table. Now, choose the data in the pivot table by pressing Ctrl+A. Go to the Insert tab, click on the clustered bar chart under the Insert column or bar chart icon, as shown on the screen. You will get the following chart, as shown on the screen. Next, select Chart Elements, Axis Titles, Chart Title, Data Labels, and Legend. In the next step, we must set up the axis and chart titles. As you can see in the image, the region contains a drop-down box where you may select a specific region or set of regions to display in the bar chart. Now that the chart is set up, let us see the different maneuvers that we can follow to customize the chart. To show only North Region sales, choose only the North Region in Region drop-down and click OK. This will be the resulting chart. Now, let us sort the values based on the descending North Region sales. Click on the pivot chart bar and choose Sort by largest to smallest. Other sorting and filtering methods can be applied on the pivot charts using the same technique. Pivot charts are widely used to represent summarized data with total and subtotals. This is essential for slicing and dicing data to investigate granularity and summing up to larger numbers. Moving on to the next topic, form control in Excel. Form controls are objects which give functionality to interact with our data in Excel. Excel provides a number of controls that are useful for selecting items from a list. The different form controls available in Excel are Label, Group Box, Button, Checkbox, Option Button, List Box, Combo Box, Scroll Bar, and Spin Button. To insert form controls in Excel, we need to first add a Developer tab in the menu. To add the Developer tab, click on the File menu. Choose Options. In the navigation pane, click Customize Ribbon. On the right-hand side of the Customized Ribbon panel, select Developer checkbox and click OK. Now to insert any form, Control-click on the Developer tab. Under the Controls panel, click the Insert toolbox. We can select and draw any form control by left-clicking any item. In the subsequent topics, we will learn how to create an interactive dashboard using different form controls, like Combo Box, Check Box, and Scroll Bars. Consider the given sales data. This table shows the net sales of 3 regions, North, West, and Middle in various months. The data in this table has been extracted from our master table by creating a pivot table, considering the fields, date, and region. In the given sales worksheet, we will add a combo box for region. So if the user selects the region as North, it shows sales of the North region only. If they select the region as West, then sales of the West region are only visible. In the combo box, we can either type an entry or choose only one item from the list. This form control always shows the current value in the text box. Here we will create a reference table shown in the range G6 to H18. Now let's insert a combo box. Click on the Developer tab. Under the Controls panel, click on Insert. Click the combo box and drag it on the worksheet. Now, right-click the combo box and choose Format Control. In the input range reference box, select the region list North, West, and Middle. In the Cell Link reference box, select Cell Q1 as our cell link. Click OK. The combo box is populated with the required list. If we click on Combo Box and select North, the cell link value becomes 1, because North is the first item of the product list, and so on. We will use offset function to fetch sales amount information from the main table into the reference table based on the cell link, which is connected to the combo box. Write the offset function in cell H7. Type =, function name, offset, then open parenthesis. The first parameter is reference. We will select the cell B6. For the second parameter rows, insert function as row open bracket, close bracket, -6. Row open bracket, close bracket, -6 returns 1. Row open bracket, close bracket function returns the current roll number. For third parameter calls, select the cell link that is the cell Q1. And close parenthesis. Now copy and paste the formula in the other cells as well. Now create a column chart for the reference table. This chart also gets connected to the combo box. If we select the region as West in the combo box, the reference table and chart displays the values of the West region. If we select the region as Middle in the combo box, the reference table and chart changes accordingly. Next, we have chart with checkbox. The checkbox control is used when we want to analyze multiple categories or items at the same time. We can select more than one checkbox at a time on a worksheet. Consider the sales table used to analyze sales in various regions, North, West, and Middle. Here we might want to compare the sales between North and West, or Middle and North, or Middle and West, or any other combination. In this case, the checkbox control can help us. First, we will create a reference table shown in range B15 to N18. Now let's insert a checkbox. Click on the Developer tab. Under Controls panel, click on Insert. Click the checkbox and drag it on the worksheet. Here we will insert 3 checkbox control, inserting the region North, West, and Middle. Let's add labels to this control. Select the checkbox, right-click on it, and choose Edit Text. Insert the name as North for the first checkbox. Change label to West for the second checkbox. and change the label to middle for the third checkbox. Now add a cell link to each checkbox. Right-click on the checkbox and choose Format Controls. In the Format Controls dialog box, go to the Control tab. In the Cell Link reference box, select Cell A16 as our cell link. Click OK. Do the same for the other checkboxes as well. Assign cell link as A17 to checkbox West. And cell link A18 to checkbox Middle. Now if we click and select the north checkbox, the cell link value displays true. Do the same for the west and middle. Now, if we uncheck the north checkbox, the cell link value changes to false. We will use the if function to fetch sales amount information from the main table into the reference table based on the cell link, which is connected to the checkbox. Write if function in cell B16. Type =, function name as if, then open parenthesis. The first parameter is logical test. Here we will enter the test as $A16 equal true. In second parameter value, if true, we will select cell B7. Leave the third parameter, value if false, as blank. Copy and paste the formula in other cells. Change the row number, that is the second parameter, for each formula. Now create a line chart for the reference table. This chart gets linked to the checkbox as well. If we select any item in the checkbox, the reference table and chart gets updated accordingly. Let us now understand the concept of chart with combo box. Dynamic charts in Excel allow us to interact with the chart and change visualizations based on criteria. The combo box chart has a drop-down list of values to choose the x-axis variables from the data table and dynamically changes the chart based on the chosen value. Let us understand this with an example. The CGPA of students are stored for 3 subjects. Based on the drop-down chosen, the bar graph changes data to show a subject chosen. Let us understand the concept of chart with scroll bar. Form controls can be used to dynamically change the appearance of Excel charts. One such control is by using scroll bar, which can change the data as shown in the chart. The charts are created in the usual manner, but a scroll control is added to provide viewing the chart by moving vertically or horizontally. This is especially useful if the size of a chart is large, with large number of data elements in the dataset. In this given chart, the marks of 25 students are available, but only 5 are visible at a time. The scroll bar enables to scroll horizontally to view other students' data as well. The last one is interactive charts. Scroll bar controls allow users to scroll through a list of pre-formatted values or texts. Consider the given sales table. This table shows the net sales of 3 regions, North, West, and Middle in various months. Suppose we want to display data up to only 3 months at a time here. We shall use a scroll bar to scroll between the months. First, we need to create a reference table, like one shown in range B15 to E18. To insert a scroll bar, click on the Developer tab. Under Controls panel, click on Insert, click the scroll bar, and drag it on Worksheet. Now, right-click on the scroll bar and choose Format Controls. In the Format Controls dialog box, go to Control tabs. The minimum value is 1, and the maximum value is 10. In the Cell Link reference box, select cell A15 as our cell link. Click OK. Now if we click the forward button in the scroll bar, then the value in the cell box increases by 1. We will use an offset function to fetch sales amount and information from the table to the reference table based on the cell link, which is connected to the scroll bar. Let's write offset function in cell C15. Type =, function name, offset, then open parenthesis. The first parameter is reference. We will select the cell B6. For the second parameter rows, insert function as row, open bracket, close bracket, -15, because we want to print the first row value from our table. For the third parameter calls, select the cell link, that is cell A15. And close parentheses. Now copy and paste the formulas in the other cells. Change the third parameter and increase the calls parameter by 1. Now, copy and paste the formulas in the other cells as well. For each cell, change the second parameter rows as required reference row number. Now create a column chart for the reference table. This chart also gets connected to the scroll bar. Now, if we click the forward and backward button on the scroll bar, the value cell link increases. The next value is reflected in the reference table and the chart. We can also insert other controls, like a spin button, radio button, scroll bar, etc. All of these controls work in Excel with the help of the cell link property. It's up to us which control we want to use in order to create a dynamic report. Dashboard is a graphical representation of our data, which initiates action. In this lesson, we have created a chart with a combo box, check box, and scroll bar to show sales in different regions. In the same way, we can add multiple interactive charts depicting other fields to design our dashboard. Now that you have learned the principles of dashboarding, how to create interactive charts, and create worksheets from form controls, let us do a small exercise to reinforce the concepts learned. We will provide you a step-by-step assistance to do this exercise. Let's start working on it together. You are the sales manager of XYZ company. You are given a sales report that depicts the amount of sales done for the product, AB, in the year 2015. The table also includes the percentage of sales amount by total. You are required to create a chart with two axes, primary axis for sales column chart, and secondary axis for percentage of sales amount line chart. You are also required to change the background of the chart and set the color of the column chart as orange and color of the line chart as green. Let us consider the given dataset, which contains the iPhone sales data categorized by customer name and age. The objective here is to create a histogram based on the age group of customers. Now let us look at the steps to create a histogram. The first step is to open the file histogram.xlsx. Then, create a new column G with label as bin. Now, insert values less than 25. 25 to 35, 35 to 45, 45 to 55, and greater than 55 in column G. Next, create a new column H with label as max of each bin. Here, insert values 25, 35, 45, 55 in column H. Now, click on Data tab and select Data Analysis. Here, choose Histogram and click OK. Next, choose Input Range with the H column values. Now choose Bin Range with column H, then click on Labels checkbox. Here, select Chart Output Range as J2. Now, click on Cumulative Percentage checkbox. And finally, click on Chart Output checkbox. Now we have a histogram based on the age group of customers. Let us create a primary chart, which depicts a sales column chart in orange, and a secondary chart, which depicts a percentage amount of sales on line graph in green. The steps involved in creating the primary chart are as follows. First, open the file charts.xlsx. Next, choose the complete data. Now, click on Insert and choose 2D column chart. Then, click on Format and choose Series Percentage. The next step is to click Format Selection. Change the plot series to secondary axis. Now, right-click on the chart and choose Change Chart Type. Finally, choose Combo Chart and change Percentage Chart to Line Graph. In this exercise, let us look at the steps involved in creating the secondary chart. The first step is to right-click on Chart and choose the Format Plot area. Next, change the line graph fill color to green. Now, change the column chart fill color to orange. And finally, change the chart fill color to blue. Let's recall what we learned in this lesson. Michael now understands how to create interactive dashboards and charts in Excel. He learned that dashboard reports help users to analyze data and take appropriate actions. He learned that charts represent the data graphically, making it easy to highlight comparisons and trends. The thermometer chart depicts how much target one has achieved. He understood that a Pareto chart contains a line graph, which represents the cumulative total, and a bar chart, which represents the individual values in descending order. He also understood that form controls are objects that allow one to interact with the data in Excel.
Certification free day. जानी परुनी पांचटा जिनस मु दिन रे केमिति कर दउछि से जानिनी मु चैट जीपीटी समाज करछि से जानिछि चैट जीपीटी बुझिलु यूज करी आसिले तो हबो ସେଥିରେ ମୁଁ ଅଧା ଖାଇ thumbnail chart is specifically used to show each of the following data effects processes देखिए मौसाठ है ऑफिस
Hello, and welcome to the Business Analytics Excel course offered by Simpler. In this lesson on analytics with Excel, we will look at how Excel helps us and improves our ability to collect, analyze, and forecast financial and business data to produce valuable insights in representation. Let's say we need to calculate a missing value from a given data. We decide to solve it on our own and try hard by plugging in different numbers till we find the correct answer. This consumes a lot of time. With the help of the What If Analysis feature in Excel, it's easy to experiment with data in no time. With the help of this feature, it is also possible to experiment with incomplete data. In Excel, there are various What If Analysis tools available, such as Goal Seek, Data Tables, and Solver. Let us take a scenario to understand and use these tools in detail. Suppose we want to buy a house through a home loan facility offered by a bank. We need to calculate the terms of the loan. With the help of the What If Analysis tools, we can calculate it easily. Goal Seek helps us to evaluate the payment formula and return new values for the rate term and the principal to fit our desired payment. With Goal Seek, we can even work backwards, that is, starting with the result. Data tables allow us to do a comparative analysis of the available data. It also allows us to review the result in the table without changing the original formula's references. With the Solver What If Analysis tool, we can find an optimal solution for a formula in one cell by adjusting the values in the other cells according to our specifications and constraints. Before going into details, let us start this lesson by defining the objectives.